Hi, in this video we're going to be talking about ABGs. Let's get started. ABG stands for arterial blood gas. When solving ABG problems, you're going to have to consider three things. You're going to have to consider the pH level, the level of CO2 in the blood, or the PaCO2, and then the level of bicarbonate, or HCO3, in the blood. The normal pH level is between 7.35 and 7.45. When completing ABG problems, the pH is ultimately going to determine if you are in a state of acidosis or alkalosis. The normal range for pH is between 7.35 and 7.45. So a pH less than 7.35, we are going to be in a state of acidosis. A pH greater than 7.45, we are going to be in a state of alkalosis. The normal PaCO2 level is between 35 and 45. Think of PaCO2 as an acid. Instead of carbon dioxide, think carbon diacid. So if the PaCO2 is greater than 45, we are going to be in a state of acidosis. If the PaCO2 is less than 35, we are going to be in a state of alkalosis. Because remember, PaCO2 is an acid, so the more and more you have of it, you're going to be in a state of acidosis. The less and less you have of it, you're going to be in a state of alkalosis. The normal bicarb level is between 22 and 26, but some sources might say it's between 22 and 28. So just refer to whatever your textbook or your professor wants you to go by. But for this video, we're going to stick with the range of 22 to 26 as the normal. Think of bicarb as a base. So the more you have of it, the more alkalotic or basic the situation is going to be. And the less you have of it, the more acidic or in a state of acidosis you're going to be in. And so a bicarb level greater than 26, we are going to be in a state of alkalosis. A bicarb level less than 22, we're going to be in a state of acidosis. Now let's do some practice problems. But before starting, it's going to be very helpful to know the acronym ROME. What is Rome? The capital of Italy. Just kidding. Do not click off the video. ROME stands for respiratory, opposite, metabolic, equal. So what this acronym is telling us is that if we have, let's say, respiratory acidosis or respiratory alkalosis, the pH and PaCO2 levels are going to move in opposite directions. So if we have a pH that is lower than normal and a CO2 that is greater than normal, we are in a state of respiratory acidosis. And if we have a pH that is greater than normal and the CO2 is less than normal, we're going to be in a state of respiratory alkalosis. And then as for metabolic, the pH and the bicarb levels or the HCO3 levels are going to move in the same direction. So if we had a pH that is lower than normal and the bicarb that is lower than normal, we are going to be in a state of metabolic acidosis. But if we had a pH that is greater than normal and a bicarb level that is greater than normal, we are going to be in a state of metabolic alkalosis. Now let's do some problems. One more tidbit before we get started. The PaCO2 correlates with the respiratory system. And so if the PaCO2 level is abnormal, that means there's something wrong with the respiratory system. Either you are hypo or hyperventilating. If you are hypoventilating, that means you're retaining a lot of CO2, and that's going to put you in a state of respiratory acidosis. But if you are hyperventilating, that means you're blowing off a lot of CO2, and that's going to put you in a state of respiratory alkalosis. but we'll get more in depth regarding that in a different video. And then as for bicarb correlates with the renal system. So if something is abnormal regarding the bicarb level, we know that there's a problem with the renal system. Either your kidneys are retaining too much bicarb or it's excreting too much bicarb. Let's get started with our problems. The first problem, the pH is 7.41, the PaCO2 is 41, and the bicarb is 22. So the pH is normal because it's between the normal range of 7.35 and 7.45. So there's no issues regarding the pH. That's good. The PaCO2, that level is also normal because 41 is between the normal range of 35 and 45. So no issues with the respiratory system. And then bicarb, the bicarb level is 22, which is within the normal range of 22 to 26. And so there's no issues coming from the renal system. All across the board, all the values are normal. And so this is a normal situation. There's no issues going on whatsoever. Moving on to our next problem. The pH is 7.47, which is greater than normal, and so we are going to be in a state of alkalosis. Now, to determine if this is a respiratory alkalosis or metabolic alkalosis, we're going to have to look at the relationship between the pH and PaCO2 and the relationship between pH and the bicarb. So the PaCO2 is 30, which is less than normal, and then the bicarb is 25, which is normal. So if we look at the relationship between the pH and the CO2, they're moving in opposite direction. And if you remember Rome, respiratory opposite. So respiratory, the pH and the CO2 are going to move in opposite directions. Thus, this is respiratory alkalosis. Moving on to our next problem, the pH is 7.28, which is less than normal. So that tells us automatically that we are in a state of acidosis. The PaCO2 is 33, which is less than normal, and then the bicarb is 18, which is less than normal. To determine if this is respiratory acidosis or metabolic acidosis, we're going to have to look at the relationship between the pH and CO2 and the relationship between the pH and the bicarb. Think back to Rome. Respiratory opposite. So if this were respiratory acidosis, the pH and the CO2 would be moving in opposite directions. That's not the case. So then let's consider if this is metabolic acidosis. The pH and the bicarb are moving in the same direction, and both of them are trending downwards. So yes, this is a state of metabolic acidosis because the pH is lower than normal and the bicarb is lower than normal. They're both moving in the same direction. Moving on to our next problem. The pH is 7.32, which is lower than normal, so this automatically tells us that we are in a state of acidosis. Let's look at the PaCO2, that's 54, which is greater than normal, and the bicarb is 34, which is also greater than normal. Think back to Rome. Respiratory opposite. So if this were respiratory acidosis, the pH and the PaCO2 would be moving in opposite directions. And this is true of this problem. So this is respiratory acidosis. And then moving on to our last problem, the pH is 7.5, which is greater than normal. So this automatically tells us that we are in a state of alkalosis. Now let's look at the PaCO2 and the bicarb. The PaCO2 is normal, and then the bicarb is greater than normal. Think back to Rome. The pH and the bicarb are moving in the same direction, so this is metabolic acidosis. Now, for some of your ABG problems, you might be asked to determine the compensation status. I'll talk a little bit more about that in the next video, but for now, that's it. I hope this brief introduction to ABG problems and how to solve them have been helpful. Please like, subscribe, comment, and share.